Well, thank you very much, and thank you for the opportunity to come and speak with you today. As been said, my name is Galen Heinrichs. I'm from the City of Saskatoon Water and Sewer Department. And I just wanted to talk to you today a little bit about some of the basement flooding solutions we've had in Saskatoon. So first, just some background, a little bit of geography, just to orient you as to where Saskatoon is if you're not sure, and a little bit about our two separate sewer systems in Saskatoon. I'm going to go over how basements flood, and I apologize that some of this material has already been gone over. So if this is not new to you, I apologize for that. Hopefully, maybe for some of you that are maybe not as familiar with the basement flooding situations and why these occur, I have some animations that might be helpful for you. So I'll go through that quickly, and then I'd like to talk about the programs that we have in Saskatoon to reduce the risk of flooding. There are some small-scale solutions and also some infrastructure solutions. So quickly, first a little bit of geography. Thanks to Google Maps here, you can see Alberta, Saskatchewan, Manitoba. Saskatoon is located in sort of south-central Saskatchewan, and we're along the South Saskatchewan River, not the North Saskatchewan. The South Saskatchewan River actually starts as the Bow River, going through Banff and Calgary, meets the Old Man River going through Lethbridge, and then continues on to Lake Diefenbaker. Lake Diefenbaker is created by Gardner Dam, which is the largest embankment dam in Canada and one of the largest in the world. And it's a very large asset to the city of Saskatoon, both from a flood protection standpoint, because Lake Diefenbaker is an enormous reservoir, but also from a water quality issue. The city of Saskatoon has much better water quality as a result of having a dam upstream. So the South Saskatchewan River just meets the North Saskatchewan, which you may be familiar with, which goes through Edmonton, around Prince Albert, and of course that goes to the Lake Winnipeg. What you might not know is Gardner Dam also creates an artificial connection to the Qu'Appelle River, which goes to the Assiniboine. And the Assiniboine River, of course, in Brandon has been in the news a great deal lately with all the flooding that they've experienced there. And that, of course, connects through the Red River. And then the Nelson River, I understand, is the next river that they're worried about seeing large-scale flooding on. So those are all interconnected. So a little bit about Saskatoon and our sewer systems. Saskatoon has been very fortunate, I guess. We've always had two storm sewer systems right from our inception back in 1906. There's a storm sewer system and a sanitary sewer system. We've never had a combined sewer operation, and they have always been kept separate. Storm sewer systems, of course, are anything related to catch basins, the ponds you see in the neighborhoods, and the water that you see on the street is all storm sewer related. So our system contains rainwater. It's never connected to homes, and it ends up in the South Saskatchewan River, primarily untreated, aside from what is settled out through ponding systems. Sanitary sewer system, or sometimes called the domestic sewer system, is the sewer systems connected to your basements, connected to your floor drains. It eventually ends up at the wastewater treatment plant, and it's always connected to every home. You would never have a home that did not have a connection to that system. So in Saskatoon, what that means is there's no household sewage in our storm sewer systems. There are no roof or downspout leaders and no catch basins connected to our sanitary sewer systems. So those two things are kept separate. All right, well, how basements flood. I'll go through this because it's relevant to the solutions we have. It all starts with seepage, and weeping tile, of course, is the solution to the seepage problem in basements. But the problem that creates is sanitary sewer overflows. So it all starts right here. When your house is built, they dig an excavation and create a hole in the ground. And one of my colleagues often says, well, of course you have basement flooding. What do you expect? You dug a hole in the ground. So that's exactly what happens. When you dig a hole, it fills with water. That shouldn't be a surprise to anybody. What may be a surprise to you, though, is when you put a house in it, that doesn't remarkably change. The backfill zone that is put in beside the house has air in it. It's because it's disturbed soil, and as a result of having air in it, it can transmit water. And so when water falls from downspouts, as we saw, it can go right into that backfill zone, and we've seen it go so rapidly as if it isn't even there. So what happens is that water builds up, and that water builds pressure. It finds cracks in the foundation and in the footing and places like that, and it goes into the home in the form of seepage flooding. Sometimes groundwater tables that are quite high can also influence this as well and cause the same sort of problems. Hopefully your basement walls aren't deflecting quite that much, but anyway, you get the idea from the illustration. So seepage flooding is common in Saskatoon for homes that were built prior to 1960. Before then, there wasn't a great deal of things you could do about this, but around that time is when we started seeing building codes and building practices change. And the solution that was that came about was, of course, to put weeping tile in, which is just simply a perforated pipe. And so the water can go, as you can see, it's coming from a downspout there through the backfill zone and fills up that pipe. Weeping tile is sometimes a confusing term to people. It comes from the idea pipes used to be made out of clay tile, and a weeping pipe was one that had holes in it, just like you can see here. And so it was termed a weeping tile pipe because it was clay tile. It's not made out of clay tile anymore. This is a plastic pipe, of course, that was normally used. But the terminology has stayed the same. I often find when I'm communicating with homeowners, the concept of weeping tile seems to be a problem for them because they don't quite understand what you're talking about, or where's this bathroom tile sort of looking thing in the house or whatever, but it's not. It's a pipe. So that, as we've seen already, the problem here that occurs is that weeping tile pipe is connected directly into the floor drain. And so it goes into the sanitary sewer system. Under normal circumstances with just a little bit of water, that's not much of an issue. So here you can see a floor drain, and here if you take a look, you can see the two outlets right into the floor drain where the weeping tile goes to. And you can see it pouring right there. And so that's a modest trickle, but during a rainstorm event, it's kind of like everybody in the subdivision goes and turns the water taps on all at the same time. And assuming the water system could take that, that's the sort of effect you have. It's not people flushing the toilets at different times. It's everything all at once occurring. And so even what might be a modest amount of flow, when it contributes in that way, can be very, very devastating. So in Saskatoon, unlike London, this is the system that we had up until 2003 in the city of Saskatoon. So from 1960 to 2003, all homes in the city of Saskatoon would have had a system similar to that. Saskatoon is a city of about 225,000 people. The greater Saskatoon area is about 260,000. But over half the homes in Saskatoon, so probably in the order of 30,000 homes, would have a system like this. So it's not just a problem that shows up in one neighborhood, it's a problem that's in many respects citywide in large areas of the city. So how does this weeping tile overload happen? Well, I've got a house here that's got its water from a rainstorm going into the weeping tile system, into the sewer. And I've got a house downstream that's having a sewer backup. And the reason that occurs, of course, is those sanitary sewer lines are connected. And indeed, all sanitary sewer lines in the city are ultimately connected to each other. And so what you'll get is a water level or a hydraulic grade line that will occur in the sewer system, and when it intersects the basement, the water is going to pond there and then come up as a sewer backup. So what's happening is this rainwater right here is finding a path, and it's finding a path all the way down to the lowest basement, or the lowest homes, and coming out here as a backup. So this is exactly what you have. It comes in through the weeping tile and then exits as a backup and is stored there until it can drain. And it's very obvious when we go out and take a look at these subdivisions afterwards. You can see the hydraulic grade line intercepts that manhole outside there, and sure enough, when you go and open up that manhole, you'll see what I see here, which is water right up to the surface. So whatever water level you see in that manhole, that's the water level it's going to be in the basements that are surrounding that. So that's a little bit about how basements flood. So what are we doing to reduce the risk of flooding? Well, as I said, we have some small-scale solutions and some large-scale solutions. I'd like to talk about both of those. So just to continue on here with my explanation regarding sump pits and backwater valves, the solution after 2003, the municipalities did this, was to mandate that new homes would not connect. And so rather than, of course, going to a floor drain, the water just simply goes from the weeping tile straight into a sump pit and then it's pumped out. And of course, it's very important that if you're ever involved with this, make sure that when they're pumping out the water, that they extend that lead past the backfill zone, because if you don't, you've just got this vicious circle where you're pumping water out, it goes through the backfill zone and then continues on. So it has to, in order to make the cycle properly, it has to go on past that area. And as you can see here, this is what we have now in Saskatoon, is a system where that sump water or weeping tile is directed to the storm sewer system and not into the sanitary sewer system. The second part, of course, is that all new homes have to have a backwater valve. And again, for those of you who may not be familiar, a backwater valve can go in at the connection. It can also go in on offshoot lines or branch lines off of the sewer connection. This is what we'd be calling a normally open valve. So when the valve's in an open position, it allows the sewage to drain from the house normally, and when it receives pressure from the other side, it just simply closes the valve and won't allow sewage to come out. The important consequence of this is, of course, if you use your household plumbing while that valve is closed, that sewage has nowhere to go. And so you'll see people sometimes that have valves, they'll say my basement flooded, and then you find out, well, they were running a dishwasher, or they were doing something else in the house that would have resulted in their own sewage causing that problem, because in fact the backflow valve did close. So what the city of Saskatoon did, as in a means to encourage people, we have what was called the flood protection program. We had a number of severe rain events in Saskatoon that caused basement flooding. I'll get into that in a minute. But I just wanted to show you what our flood protection program did, sort of in contrast maybe to, or in many ways similar to what the City of London did. Our flood protection program asked people to put in a backwater valve and a sump pit. So this is just to upgrade their plumbing. And this is for any house that was not up to our January 1, 2004 standard. And we selected the homes very specifically. There had to be a demonstrated risk of sanitary sewer backup. So the way we did it is we funded it off a $3 levy per water meter. So following the severe rain event in 2005, we went to council, we said we need money to solve some of these problems. So they instituted a $3 levy. We actually had some more severe storms, and that was raised to $4.50 per water meter in 2007. That's the funding source for this flood protection program, and also the Superpipes, which I'll show you in a minute. Any home that was deemed to be at risk of sewer backup could upgrade their plumbing with the backwater valve and sump pit. In our program, the city paid 100% of the costs, up to a ceiling of $2,500. We ran the program 3 times, once in 2005, once in 2007, and then in 2010 we ran it again and upped it to $3,000, and coincidentally plumbing prices went up by $500. It's a lesson in economics there somewhere. So in 2005, you see the numbers for the homes that we offered it to. And our participation rate in these programs, you can see there, was pretty consistent actually, all around the 50% level. So we only had about 700 homes that actually took us up on the program. One of the things we did after, that was sort of a disappointing rate to me, although as I've come to understand that's not a bad rate compared to some other municipalities have done. We undertook a survey to find out why is it, like we asked people after the 2005 program, and only half the people took it up. We did a phone survey, and we phoned every homeowner that had refused the program. We had a consultant do this for us, and we asked them why didn't you want to be part of the program. And I was hoping, from sort of my statistical background, that I was going to get a bunch of responses from that open-ended question that I could say, here's the answer. Turns out it was all over the place. There were a number of different reasons why people didn't want to do it. They ranged from many of the common things we've already heard. We think it's the city's problem, it's not our problem. This is an unusual event, we don't want to do it because we don't think it's going to happen again. I would say if there was a common thread, I suppose a large number of the complaints were simply they didn't want the mess that occurred from putting in a backflow valve at a sump pit. It's dirty work. You have to bash open the concrete in the basement. You have to haul mud out to get the sump pit in. It's a lot of disruption. And so I think maybe if there was a theme that fit, say, 25 to 30% of the responses, it was probably something along the hassle or the aggravation of having to have the upgrade done. So unfortunately, I couldn't come up with any especially conclusive results from that survey. What we did find out, though, because we had several flood events that occurred over the same areas of the city, is we would go back and look at the places, the homes that had done the plumbing upgrade we'd asked them to do, and they were in an area that we would have expected flooded again. And we went back to see how they did. And what we found was that the backflow valve was 85% effective in eliminating sewer backup. So in other words, a home that I would have expected to flood, put in a backflow valve in 2005, flood occurred in 2007, and they didn't have a flood any problems. 96% effective in reducing the damage from sewer backup. So when I look at those 15% of homes that did experience some sewer backup as a result of putting a backwater valve in, many of them had much reduced damage. So they had a puddle in their utility room, or they got a carpet that was wet, or they had a flooding incident, but it wasn't a flooding incident nearly the magnitude that you might have expected. And a lot of times that's just simply from a maintenance standpoint for the backwater valves. We try to encourage people to look at them, especially in May, the beginning of the spring season, and if there's some hair or debris or something that has accumulated on that valve, it's not going to do its jobs effectively. So inspecting and maintaining that backwater valve is important. And as you can see, it can be quite effective. So large-scale infrastructure solutions is sort of where a lot of the emphasis that the city of Saskatoon has put on this as a municipality, so I thought I'd talk about that a little bit. But before I do, I want to tell you why, what we had for severe rain events in Saskatoon and what the consequences were. So this is just a few of the storms we've had in Saskatoon. This is sort of our big event. It occurred on June 24th, 1983. We had 96 millimeters of rain, we had 75 millimeters inside of 45 minutes. And so the consequences of that were extreme. This is an intersection that was severely flooded during that particular event. You can see what happened there. So this was a 24-hour rainfall record. There were probably about 2,000 flooded homes, although I can't be entirely certain about that data because it's just not. We know what homes flooded and we know some information about it, but trying to separate things from sewer backup from the sort of surface flooding you have here is a little bit difficult for that event. But nonetheless, it was a landmark event. We had a very minor event here in 1994 where we had 50 flooded homes. But after that, things kind of picked up. In 2005, this was sort of when I came onto my job of looking after sanitary sewer storm flooding. We had a rain event only 56 millimeters, and I would point out not a very severe one as far as intensity. This was 56 millimeters, maybe draped over, I'd say 3 hours, 3.5 hours, something like that. So not something I would have expected a lot of flooding from. We had 800 flooded homes, and probably double that again in seepage from that particular storm. And so this was kind of a what happened here moment for us. And when we looked at it in retrospect, there was actually a 30-day period where we had 160 millimeters of rain. In fact, it was the wettest 30 days that we'd seen since 1939. And what happened was that wet period we had before had sort of primed everything up. So everything's wet, the water has nowhere to infiltrate, nowhere to go. All those backfill zones are already full of water. And so what happened is the water came and it all had nowhere to go but into the sewer system. So that was a 2005 event. In 2007, we had 102 millimeter rainfall, which established a new 24-hour record, although it wasn't quite as intense. But nonetheless, we experienced 500 flooded homes on that day. In 2007, we had a 59 millimeter rain event that was reasonably severe, and this was a puzzling one too. There were no backups that day. We went around. It was a Friday night, and we went around on Saturday looking for homes that had backed up and we couldn't find any. But not to worry, because we got 46 millimeters of very intense rain less than 48 hours later. And so as a result, those two storms combined for 108 millimeters, which is our new 48-hour record. And so those two storms combined, it's a similar thing to what happened in 2005, just in a shorter time period. So we got hit, and then we got hit again. And I have a little bit of, this is a satellite radar image, courtesy of Environment Canada. This is what they call a mesoscale convective complex in Saskatoon. You can see a line of pink just along there, and that line of pink is going to go right across the city of Saskatoon. That's the path that the storm took, and so that sustained heavy rainfall is just going to go right across the city. So this is an image taken about an hour later as it's coming across the city of Saskatoon. So that was on August 17th, and then on August 19th, you can see this storm hit us, and you can see the pink there again, and the same thing, it just tracked straight across the city. And the combination of those two storms ended up causing a lot of flooding. So these were mesoscale convective complexes, all three of those storms, and we suspect that one is, although we have no radar imagery from it. And then our latest one was on 2010, June 29th. We had 400 flooded homes, 85 millimeters of rain. And the 30-day rain period was 169 millimeters preceding that one. So our wettest 30 days got beat just 5 years later. We had about 400 flooded homes from that event. So this is the events that we've had here. Just one other little point here is the top 10 highest rainfall years in Saskatoon. You can see where 2010 ranks. It beat our 1923 record by 100 millimeters. And you can see that 4 of our wettest 10 years have occurred in the last 5 years, from 2005 to 2010. So conclusions. Unfortunately, lots of observations, but not many conclusions. We can observe that we had 4 of the 10 wettest years in that period. We know that these were mesoscale convective complexes, which is sort of the large-scale thunderstorm you'd see in maybe the U.S. Midwest. It'd be a more commonplace to see that. This was just a garden variety thunderhead, cumulonimbus cloud. These two are what you'd call synoptic rain events, but when they were combined with the antecedent rainfall, or the rainfall that came prior to them, they also caused flooding in Saskatoon. And as far as intensity and duration frequency curves, these are the only two that would have ranked as actual 1 in 100-year events. But as you can see, the combination of events in the other cases also caused problems as well. So what this amounted for us is a new approach to assessing what we're looking for in storms, and what new solutions should be maybe for our infrastructure. So we'll talk about the super pipes here. And maybe a little bit quickly about sanitary pipe design. One of the questions we always get also all the time is, well, why don't you just build the pipes bigger and deal with it that way? It's not quite that simple. And it's not that simple in a separated system, because the primary purpose of the sanitary sewer system is to convey domestic sewage. And when you start altering the design of that, you create problems. So sanitary sewers have to run at a minimum flow speeds in order to convey the solids that are inherent with having a sanitary sewer. It's not the same as rainwater. There's a lot of solid material and a lot of solid matter that must be conveyed as well. They have to be self-cleaning. If you have larger pipes, what will happen is the flow will tend to be less because you have to drop the slope. Solids will accumulate on the bottom, and they won't clean themselves out, and they'll just accumulate. And eventually that capacity you think you don't have anymore, because it's all plugged up. And so instead of having sewers backing up during rain events, you've got sewers backing up on a frequent basis because they're plugged and they can't do their job. They have to be deep enough to prevent freezing, not too deep so you can maintain or build them. And you can't design them for extreme events because of many of those situations. There's an actual physical limitation to what you can do with a sanitary sewer to have it do both jobs: convey this rainwater from weeping tile and try to convey sewage from your home, which is its primary purpose, of course. So this is the Saskatoon Superpipe concept. So here we have my animations again with the 2 houses that are flooding. And the idea is simply to build a tank. And you build it lower than the lowest basement in the area. And now, when the water needs somewhere to go, it goes there, not into the basements. So I often refer to them as sacrificial basements, because that's effectively what they're doing. It's a basement designed to take flooding. And so that water level or hydraulic grade line drops, and it'll be below the basement level because it's filling the tank rather than filling the basements. So, and after the rainstorm happens, we have 2 kinds of pipes. We have our tanks. We have what are called inline pipes, which self-drain, and those are preferable, but not always possible. On 2 of our tanks right now, we have to actually go after the storm and pump them out. And so we're in the process right now of putting automated systems in there that will remove that water as soon as the rainfall is passed. So, just to give you an idea of a little bit of the engineering that we had to do this. When you build a tank, it has what we call an influence zone. It can't necessarily affect the entire sanitary sewer system. There's only a restricted area that it will have an impact on. What we try to do is match those up with flood zones. So if you have a subdivision here and a set of sewer pipes or sanitary sewer pipes that are going through it, you get an idea. We can get all of the flood reports back to us as to homes that may have or experienced a sanitary sewer backup. And then you can start doing some of the same computer modeling that the City of London has already done. You find some areas of the city, these people are contributing in this neighborhood, but they're not at risk of flood. They're too high. Okay? And so when you look at the sanitary sewer line and you look at the actual topography of the area, you can quickly identify areas that are not going to be at risk of sanitary sewer backup, simply because the sanitary sewer would effectively be up to the ground level already. It would be running down the street in the gutter prior to it being able to influence any of the basements. So we've got this area here that you think may be at risk of sanitary sewer backup, and perhaps a fringe area as well. So what you're trying to do when you have a tank is you place the tank in a suitable area, usually a green space area like a park, because you can easily have lawn or playing fields over top of it. And then it has a zone of influence, which you can determine hydraulically through computer models. You try to match that zone of influence so it covers the maximum amount of area. So in this case, there would be 2 tanks. And those 2 tanks would try to to the greatest extent possible, cover that area that I've shown in red and try to mitigate the flooding damage that would occur in those areas. So the superpipe size is a difficult question. As I said, using that IDF curve is a start, but there are other combined circumstances that can also cause this problem. What we've done for now is we've taken the most extreme events we've had, we've estimated the volume of basements, the volume of water that's gone into basements, and used that as sort of a baseline as to how big the flooding tank needs to be. So that's not where it ends, but that's a starting point. So if you've had 100 basements and they've each had 30 cubic meters in them, then you need a 3,000 cubic meter tank sort of thing. Okay? So it's a combination of fancy engineering and not so fancy engineering going together to try to solve this. So here's one of them right here. This is a superpipe going in. That's a 3,000 millimeter diameter plastic pipe. You can just see this is about half of it that is exposed. The other half is already buried behind, and you can see them putting the sections together there. This is the pipe end, which actually turns out to be a fairly complicated little structure to build, but nonetheless, this is also manufactured out of PVC pipe. And this is a triple barrel pipe. This is a pipe where we've actually taken 3 of these 3,000 millimeter sections and laid them beside each other. And this, you can see the pipe in the background there. It actually goes back for about 150 meters in this case. So the Superpipe project in Saskatoon, we have local engineering firms doing the engineering for us, local contractors, local construction management, and the pipe is actually manufactured right in Saskatoon. So this has been a very successful project for a lot of those reasons, and one that's been able to gain a lot of public support as a result of that. So I'll just give you a little idea of what we've been building here. So we put 2 pipes in 2008, and you can see the sizes and costs there. We did 2 more in 2009, we did 2 more in 2010. Our plan is to build another one here in 2011, it's underway. We have 2 more going in 2012, another one in 2013. So far we've spent $10.2 million on super pipes in Saskatoon. One of the other reasons that we've taken this approach is these projects have qualified for infrastructure grants from the federal and provincial government for Build Canada and from the infrastructure stimulus programs, which I'm sure you're familiar with. And so these are examples of projects that fit into the categories of those criteria very, very well. And so we've spent $10.2 million, about 36% of that is what I call senior government funding, federal and provincial money. We'll spend $19.3 million by the time the project is done. It'll be 51% senior government money that's paid for those projects. So just a quick summary for you here. Sanitary sewers will overflow during severe rain. That's a consequence that we have to deal with as a result of the weeping tile. We've discovered that different combinations of storms and rainfalls can cause the overflows. It's not just a 1 in 100, 1 in 25 year event. It's 1 or 2 conditions ganging up on you, perhaps 2 storms, or perhaps a storm plus a lot of rainfall preceding it. And of course, we can tell it's the rainwater is the mechanism for the rainwater getting to sanitary sewer. I just point out there are other mechanisms. Certainly, there's pipe cracks and those other things that we've talked about for inflow and infiltration. From the city of Saskatoon experience anyway, given our particular infrastructure and the way that it's been designed, we've found that weeping tiles are by far the largest contributor. So some solutions, backwater valves are at least 85% effective. Our concern is trying to get people to participate in the program. And you know that 51 and 52% participation rate, those are from people who have a vested interest in putting that backwater valve in. I mean, we targeted people specifically who had had a sanitary sewer backup for the program, and that's the sort of uptake. And as they said at the City of London, the people that are upstream and the people that may be contributing to the problem, but aren't actually experiencing the results of the sanitary backup, generally aren't very interested in participating. And storage tanks can be designed to capture overflows. And I certainly, again, appreciate what Kyle had to say from the City of London. If I had my way, if engineers could run the world, we'd go in and we'd mandate that people disconnect those things immediately. I'd love to do that. Unfortunately, from a political standpoint, when you're looking at, as I said, 50% of the homes in Saskatoon having that sort of a situation, it's almost impossible politically to get that sort of a thing implemented. One thing, the highlight or the side issue to this perhaps is what we are trying to do rather is to take a different approach to getting the weeping tile disconnected. We have another thing that we can do is when you try to draw a plumbing permit to do extra work on a house, new bathroom or anything like that, we can mandate changes at that time. So we can insist that you, if you're going to go and do extra plumbing in your house, that, okay, now that you're doing extra plumbing in this house, you have to upgrade the plumbing to the newest standard, so then the backwater valve can come in and then the sump pit, and that's another mechanism that's available to try to change that. That takes time. I mean, that's not going to change things overnight, but you know, you're going to see a percentage of homes rotate over a large period of time and upgrade their plumbing. I just like to call the City of Regina and the City of Winnipeg. We work together with them, and some of the animations that you saw here is work that they've done, and they have excellent websites. I'd encourage you to look at them. And we also have a website as well at saskatoon.ca. If you go to B for basement flooding, you can see all of our public education material and information about our programs there. So thank you very much.